Good morning, students. In the last class, I explained I did all the numericals and I gave homework to you people. So calculate molarity of 2.5 gram of ethanoic acid in 75 gram of benzene. Okay. So students, for this, you have to check what moles of ethanoic acid. That is NaCH3COOH. How? So here the given number of moles is equal to given mass divided by molar mass. Okay, given mass is 2.5 gram. Molar mass is, so here it is C CH3 COOH, correct? 2 into carbon atoms 2 is there, that is 12, 24. 2 into oxygen, that is 32, and 4 into hydrogen, that is 4, you will get 60. Okay, this is divided by 60, you will get approximately 2.5 by 60 means this is 0.0417 gram. This is gram per mole. Gram get cancelled, moles. Once we got the mole, we have what? 75 gram of benzene. Okay, so listen. 1 kg of benzene is equal to 1000 gram. Okay, arithmetic into the power 3 gram. So here they given 75 gram. Then if you cross multiply, you get 75 into 1 divided by 10 to the power of 3, that is 75 into 10 to the power of minus 3 kg. Because formula of molarity is number of moles of the solute presented dissolved in 1 kg of the solvent. Here gram is there, we have to convert it into 1 kg. Then the formula molarity is equal to how much? Molarity means number of moles of solute dissolved in kg of solvent. So number of moles of solute means this one 0.0417 divided by this one 75 into 10 power minus 3. That is 0.0417 into 1000 divided by 75. So may multiply the students, you will get 41.7 divided by 75. Okay, this is approximately 0.556 mole or molar. 0.556 molar. Okay, this is the answer. Yesterday I gave this for you as a homework. Today I solved it. Okay, because there is no problem in these concepts. So next one is students, calculate molarity and mole fraction of Ki Ki if the density of 20% solution, 20% aqueous solution is 1.202 gram per milliliter. Gram per milliliter. Okay. So now we are going to check one mole fraction, molarity as well as mole fraction. What they given? Aqueous solution of Ki means Ki aqueous solution means consists of what? Ki and water. What they given? 20% of aqueous solution. If we consider it into 100 means this is 20, this is 80. Okay. So students, now we will consider first mole fraction. Okay, mole fraction means first we have to check N of Ki. How? Given mass by molecular mass. So given mass of this Ki is 20, molecular mass potassium is 39. Okay, the iodine is 127. Total 166. Okay, this is 166. So we will get the answer, students, approximately we will get 0.125. Okay, approximately we will get 0.125 or 123. Okay, next N of H2O. Given mass is how much? 80. Molar mass is 80. We will get 4.444. Once we have N of K, N of H2O, we can easily calculate X Ki and X H2O. X Ki means number of moles of Ki divided by number of moles of Ki plus number of moles of H2O. So number of moles of Ki is 0.123 divided by 0.123 plus 4.444. So we will get 0.123 divided by 5, 4.567. So listen, students, here 125 is here approximately this is 0.2, this is 0.5, 1 by 5 means we may take it as 1 by 5 because it is 0.1 is there, here 4.5 is there, 1 divided by 5 is approximately how much? 0.2. Correct? So here 4.5 means some value will be there. I hope you understood. And you may divide this, you get 0.0267. Okay, so if you minus this value with 1 and subtract this value with 1 means you get N of H2O. Okay, how much? This is 3, this is 3, this is 7, 9. 0.9733 is number of moles of H2O. So, or a mole fraction of H2O. How you can calculate in the same manner? X of H2O is equal to N of H2O divided by N of Ki plus N of H2O. If you apply the same formula, you will get the same answer, or you will subtract this value from 1, you will get the mole fraction of the water. Okay, here in this question, they have only the mole fraction of this means this is the answer. Only they ask this. So another one is what? Another one is you have to check molality. Okay, what is molality? Number of moles of solute divided by mass of solvent in kg. Correct? Number of moles of solute, that is 0.125 and 3 approximately. Mass of solvent in kg. Mass of solvent they given here what? 80. That is gram means that is 10 raised to minus 3 kg. Okay. Then you will get 0.123 into 10 power 3 divided by 80. That is 123 by 80. So this is 123 divided by 8. So this is 8 1 8.23 is there. 43, 8 by 40, 1.56 more. So this is the answer, molarity. You may check it for molarity also, student, because here density they given. Okay, you may check it molarity also. How? I'll drop this. Molarity means number of moles of solute divided by volume of solution in liter. Remember here the given is ml. ml means 10 raised to minus 3 liter. So here number of moles. Volume how can we will get? So you know mass is equal to density is equal to mass by volume. So volume is equal to mass by density. Okay. So mass of Ki is 160. Density is 1.202. If you divide the students, you will get the answer. One 133.111. Okay, so this much of ml. If we convert it to liter means 133 into 10 to the power of minus 3 liter. Okay, once we got the volume means apply the formula. Molarity is equal to number of moles means 0.123 divided by 133 into 10 power minus 3. Okay, so we'll get you will get 1.72 more. 0.72 more. You can calculate it, students. You will get this much. So why this density helps means because you want volume. Okay. This is all about this. So we calculate molarity and mole fraction of Ki. If the density of 20% of aqueous solution is 1.202 gram per ml. Okay, these are very important. As I told you, this is also important for 3 marks because in this molarity also asked, molarity also asked, mole fraction is also asked. Okay, so this is all about numericals. Then we will discuss about the solubility of solute particles in the solvent particles. solubility. In the solubility of solids in liquid is there and gases in liquid is there. Okay, so in students, as I told you, in this chapter we are going to study only about the liquid solutions. We are going to study only about what? Liquid solutions. Here, solids and liquids, whether they are soluble or not, how the temperature affects, how the pressure affects. Next, gases and liquids, how these affects and what is the uses and all we are going to study. So first I'm going to say is, so solids dissolves in liquids. We are going to check what? The solubility of solids in liquids. So students, before going to explain the solubility, I will say about the solution. In the solution we use what? Most of all, solute and solvent. Solute is the concentrate solid. In the solution, if any one of the component is less in concentration, then it is said to be solute. If any one of the component is more in concentration, then it is solvent. Okay, in the solute and solvent, the solid and liquid means of course solutes are in solid state and solvent is obviously liquid state. So in that dissolution also, and how the solids dissolved in solid dissolved in liquid, it takes types also. For example, take the example NaCl and also KCl. Next, naphthalene and anthracene. Okay, so students, these are easily soluble in water, insoluble in benzene. These are soluble in water and insoluble in, right here, water and insoluble in benzene. Okay, but these two soluble in benzene but insoluble in water. What it means, students? These NaCl and KCls are very readily soluble in water but not in benzene. You know benzene is also student solvent, water is also a solvent. But water is called as a polar solvent, benzene is called as a non-polar solvent. And here, this Na is splits into what? Na plus and Cl minus. This water is also H plus and OH minus. But the benzene cannot be dissociated as plus and minus ion, and this naphthalene and anthracene also cannot be dissociated as plus and minus ions. So here what happens? So these are called as what? Polar molecules. So this is polar solvent. So this is non-polar molecules. This benzene is polar solvent. Okay, so students, here what it shows clearly, polar molecules are dissolved in polar solvent only, non-polar molecules dissolves in non-polar solvents only. Because that's why I told these two are soluble in water but insoluble in benzene. These two are soluble in benzene but insoluble in water because these two are non-polar molecules. So the statement which suggests that this is like dissolves like dissolves like. That means, students, if polar molecules are there, then we require polar solvent to dissolve them. If non-polar molecules are there, then we require non-polar solvent to dissolve them. Okay? So this is solids in liquids. So in the dissolution, so listen, the solute particles. What it is called as solution? And write here. As I told you, solution means solute dissolved in solvent and increases concentration in the solution. Okay, so students, this solute dissolved in solvent, or dissolved in what? Liquid and increases the concentration in the solution. If a solute, for example, salt is there, if salt is dissolved in water, then the concentration of the solution increases. It is called as what? Salt solution. The concentration of salt is there in the water. Okay, so this solute dissolved in liquid and increases the concentration of the solution is called as what? Dissolution. Is called as dissolution. If solid dissolves in liquid. If solid dissolves with dissolve in or with or mixed with in salt. Okay. Then this is called as crystallization. So you are well known about that, students. If you keep on adding in the separation method, in the purification of the sample, crystallization is there. In that crystallization mean, if we add any of the solvent in that, so what happens? That solute particles present is combined with any other solid. Okay, the solute particles present in them, dissolved in them, is dissolved with any other solute particle or any other solid compound, and they separates out, crystallizes out. Sometimes we will get precipitate, right? That precipitate may be what? The solid which is present already in the solution is mixed up with the solid which is in the added solvent, then that is called as what? Crystallization. So listen, here solution means solvent plus solute. So this attain what? Dynamic equilibrium. Dynamic equilibrium. What is dynamic equilibrium? So for example, 1 kg of salt is there, 2 liter of water is there. The maximum capacity is only 1 kg of salt is dissolved in 2 liter of water. But after, then that is called as what? The dynamic equilibrium. So here now students, if we add extra salt to that, then the added salts dissolves in the water, but the already dissolved is crystallizes out. I hope you get. The added salt is dissolved in water, but the salt already dissolved is crystallizes out. So then at that state is called as what? Dynamic equilibrium. That means the solution becomes what? Saturated. It attains the maximum saturation level. So what is saturated solution means? At the particular temperature, the maximum dissolution power of solute in the solvent is called as what? Saturated solution. At the given temperature, I am telling. So, if temperature increases, sometimes dissolution increases. If temperature decreases, sometimes dissolution decreases. So, this is what solids in liquid. This will have dissolution as well as crystallization and a dynamic equilibrium. Okay, so this is all about the solubility of solids in liquids. How the temperature affects. Okay, effect of temperature on solids and liquids. So students, as I told you, effect of temperature. This is very important. Why? I will say effect of temperature on solids in liquids. Okay, students, as I told you, dynamic equilibrium is there. Dynamic equilibrium means solution gives rise to solute plus solvent. So here what happens? How the temperature varies means if the dissolution process, if the dissolution process is endothermic. If the dissolution process is endothermic, then temperature or solubility increases with increase in temperature. Okay, if the dissolution process is endothermic, this much only effect of temperature. If the dissolution process is endothermic, then the solubility increases with increase in temperature. For example, addition of sugar to water. If you add water to sugar to water means it cools down the temperature of the water. So if you touch the students in the cup, you take some amount of sugar. I think you are very well known about the sharbat what you are often using in the summer days. Okay, that is somewhat cool students. Why? Because the addition of glucose, C6H12O is nothing but glucose we are using in the form of a sugar. Okay, so that is what the dissolution of sugar in water is an endothermic reaction. So it absorbs heat energy. So then what happens? If it increases the temperature, the solubility of what that sugar in the water increases. That is what I am telling you. If the dissolution process is endothermic, means it requires heat energy, absorption of heat takes place, then the solubility increases with increase in temperature. Okay, next. If if the dissolution process is exothermic. Exothermic means it is liberated. Then solubility decreases with increase in temperature. Okay, so these points are students. I am writing, telling you again and again and again. This is very important. Okay, this is highly important. So effect of temperature as well as effect of pressure. Okay, and then what is effect of pressure? First you observe this effect of temperature. If the dissolution process is endothermic, then the solubility increases with increase in temperature. If the dissolution process is exothermic, then the solubility decreases with increase in temperature. So why I said these are important students? Because this is the question that preferably asked for 1 marks. I told you question number 1 and 2 is from the solution chapter. In that, this is very important. What happens with the if temperature increases? What happens to the solubility of solids in liquids. If the solubility process is exothermic, then what happens with the solution or solubility if the temperature increases? Like that, they often ask students, so you have to remember this condition. How many times I'm telling you? So don't forget this. Only you have to remember endothermic means solubility increases with rising temperature. Exothermic means solubility decreases with rising temperature. Okay. So next one is effect of pressure. You know, solids are there, liquids are there. They are very, as I told you, the arrangement of the atom, solids are tightly arranged, liquid are also somewhat tightly arranged. So this pressure has no significant effect on solids in liquids. Okay, so students, the pressure never affect, so it will affect, but it is not that much significant that we can distinguish. So, in the solids and liquids, the effect of temperature is varies, but the effect of pressure is nil. The pressure cannot change the solubility of the what? The solids in liquids. If we apply pressure means already the tightly arranged. If we apply some amount of pressure also, it won't change that much. Okay, that's why pressure don't have a significant effect or a significant change, but this temperature has. For endothermic, it increases, solubility increases. For exothermic, solubility decreases. So this is what solids in liquids. Okay. Now we will discuss gases in liquids. B. Solubility of gases in liquids. Solubility of gases in liquids. So here students, so gases in liquids, solubility means you know the water is the best example. In that water, oxygen is dissolved. So the dissolved oxygen leads to the aquatic life animals to survive in the water. So the minimum amount of oxygen is dissolved in water, less amount. Okay, that requires or that is much enough to survival of the aquatic animals. That is the best example how the gases are dissolved in liquids. Okay, so nitrogen gases, there so many gases are there, students. They are highly dissolved in liquid. Some gases are there. So thus we are going to study gases in liquids. In that, effect of temperature we are going to study. Effect of temperature. What is this effect of temperature means? If temperature increases, then solubility decreases. If the temperature increases, then solubility decreases. Why? Because students, because listen, if the temperature increases, then the solubility decreases. This will compare with the dynamic equilibrium. This will compare with what? Dynamic equilibrium. So what happens? So in the dynamic equilibrium means how many solute is dissolved, that much of solute is also liberated if it is at an equilibrium. As I told before, in the solids and liquids. So same thing is applied for gases in liquids. So here what happens, students? The gases which is dissolved in water, example, are a liquid. So when it is dissolved in liquid means this gaseous molecule changes to what? Liquid molecules. Okay, the gaseous molecules are changes to what? Liquid molecules. Okay, that is compress, they'll compress. So these liquid molecules, when the rising temperature takes place, again changes to what? Gaseous molecules. Here, the process is condensation reaction. Here, the process is condensation. Condense means what? The temperature cools down. The temperature, this reaction, when gases is changes toward liquid molecules means then condensation takes place means temperature cools down means that means what? It liberates heat. It liberates heat energy. I hope you understood. So gaseous and liquid students that attain what dynamic equilibrium means the gases dissolved in liquid. These gaseous molecule changes to what liquid molecules. So gaseous state to liquid state means that is condensation. I told you. So solid to liquid, liquid to gas. Okay, this is heat is applied. Again, if they condense, again the same thing follows. So the reverse, gas to liquid, that process is called as what? Condensation means cools down. Here temperature is removed. Temperature removed means heat is liberated. If heat liberated, that is exothermic reaction. So as I told you students, if the reaction is exothermic, then the solubility decreases with the increasing temperature. That's why the gases and liquids effect of temperature is if the temperature increases, then the solubility decreases. Reason for that is compared with dynamic equilibrium that shows the condensation reaction. That condensation reaction is exothermic. If it is exothermic reaction means that shows what? So according to the effect of temperature on solids and liquid, if the reaction is exothermic, then the solubility of gas is decreases with the increasing temperature. Okay. So the next one is effect of pressure. So these are very important students effects. You have to remember this. No idea, I don't know how you will remember, you have to memorize, or you have to remember, how you understood the concept, but these things are very, very important in solids, in liquids. Okay. Next one is effect of pressure. So these are students, I'll write directly, if pressure increases, then solubility also are directly proportional to solubility also increases. How? I'll write the diagram here. So this is one piston is here. This is water molecule. This is water molecule. Okay. And these are all gaseous molecules. Okay, students. If this is the piston, move other piston, and right here, this one is piston. Same you consider if the piston is here. Okay, from here it move towards this side. Then this is water molecule. Okay, this one is gaseous molecule. I hope you understood this, students. So here two different solutions solutions are there. On the surface of the solution, gaseous particles are there. Here piston is there. When the piston is far away from each somewhat at some distance means the gaseous molecules are far away from each other. Here the dissolution is very less. The particles dissolved in water is very less. I think you are observing this. Correct? Next, if you apply that pressure, then all these gaseous molecules come closer. The intermolecular distance decreases. The volume decreases when the pressure increases means the size decreases. Then the dissolution of gas increases. Okay? So this is the piston. If we move the piston, these atoms which are far away from each other, they are dissolved in water. So this shows what? The pressure increases solubility. Okay? If the pressure increases, you will write students in this manner directly. If the pressure increases, then the solubility of gases in liquid increases. Okay, if the pressure increases, then the solubility of gases in liquid increases. Okay, so based on this pressure, students, so many scientists explain the effect of pressure. What is the law? That is Henry's law is there, Dalton's law is there, Dr. Raoult's law is there. All they are explaining about the solubility of the compounds in the liquid solutions and liquid gas solutions. Okay, so for today's class, this effects is enough, students, because that is important. I'll write it again, so you wrote down if it is possible, because very important. In the next class, I'll explain the different laws which shows the pressure, effects of pressure and effect of temperature on the solutions, binary solutions. So I'll write effect of temperature. Okay, first point right? First point, if dissolution process is endothermic, then the solubility of solids in liquids increases with increase in temperature. Okay. Second, if dissolution process is exothermic, then the solubility of solids in liquids decreases with increasing temperature. Okay, this is what solids and liquids. And this one is if temperature increases, then solubility of gases in liquid increases. Okay, so this is all about effect of temperature. If you want to come to pressure, means in solids pressure has no effect, but in gases, if the pressure increases, solubility increases. Okay, so the remaining we will discuss in the next class. Thank you.
Al menos donde todas las